Hey everyone, I'll be talking about Introduction to 3D Solar System Design, and it's about revolutionizing businesses. Um, I'll move straight up to the agenda I have. I will give an overview of solar system design, importance of 3D solar system design, why SketchUp and AutoCAD, because in this webinar, emphasis is going to be on SketchUp and AutoCAD, the market opportunities available, and the next procedure, the next step. Solar system design. I believe you're familiar with the solar system design in terms of solar installation and the execution of the project. The processes involved in power systems that has to do with renewable energy. So the solar energy market is rapidly growing. I mean, it's really growing very fast. And there's a need for innovative design solutions and competitive edge. We have many key players coming into the market. Um, there are more competitors now than there were like 2, 3, 4, 5 years ago because there's more stream in the market now. Uh people are going solar, people are going off grid, and people are running uh, independent power systems. Some are supplying to communities, some are the residential level, some are the commercial level. So that there is a need uh, for um, businessmen and women companies to have an edge uh, in the market, to have uh, a ground of difference, uh, uh, able to scale up their skills and be able to get more jobs and make more profit. So is 3D modeling. 3D modeling tool is on demand and it has become essential for solar powered projects. Project managers are requesting calling for 3D solar designs. Of course, we know 2D is part of the process, but if we are going to present something that makes us stand out, we're going to have to go above 2D and go as far as 3D. 3D is now on demand. We have software like PVSys, 3DX Max, and solar companies are hiring solar designers. I'm not talking about those who have to do with the calculation aspect, those who do the system sizing. I'm talking about designers, drafters, or AutoCAD users for them to be able to design their projects and be able to win approvals from clients and local state level meet state requirements. So in this webinar, I will explore how to use 3D design tools. And as I said, I'm focusing on SketchUp and AutoCAD for solar system layout and inverter room. AutoCAD and SketchUp is the main focus as a tool to be able to execute 3D design for solar projects. So what is solar system design? Let's start at the basic. What is solar system design? Solar system design is the process of planning and creating layout for solar installations that meets specific energy needs. Solar system design has to do with the process of planning, creating layouts for solar installations that meets specific energy needs. We all have different energy requirements, needs rather. Uh, Clients don't have the same energy needs. One may need a 15 kVA, another one may need a 20 kVA. One may decide to go off grid. Probably the location is far away from the general grid. For rural areas. And some solution is 5 kVA, some go as low as 2.5 kVA. So whatever the energy needs, there is a planning and there is need for layout for mega installations, especially those ones that has to do with powering the communities. We talk about 2 megawatt, 4 megawatt, 10 megawatts. So you need a plan. You don't just come and say you want to install. You need a plan. You need to submit your electrical drawing, your structural drawing, your mechanical drawing for approval. So this is the process and the planning is solar system design. Process, the process of planning and creating this layout for solar installations, whatever the energy needs is solar system design. And you see, the solar system design involves technical, environmental, and economic considerations. So there are things that we need to consider for us to effectively design a solution, for us to effectively design a project, and to have it executed very well, to have the project done very well and commendable. So to ensure efficient and reliable energy generation, solar power. Now, the design typically includes the following steps. Number one, site assessment. What do you mean by site assessment? What do we mean when we say site assessment? Site assessment is simply TSS. TSS, Technical Site Survey. That's what uh, site assessment means. We need to know the site. We need to know the way the site looks like. We need to know our true north. We need to know the best position for solar panels. We need to know the environment. Are they going to have shading issues? And we need to know the height, the length of the building, the distance from the power room, uh, the space we have to optimize for power generation. Those are the things we look at in TSS. And another that we have here is the load analysis. Load analysis. You know, the critical load, the loads of priority, which loads are going to be on the inverter system, which load and how many loads are there, what's the total load, the division of the load, the location of the load, and the duration of use. Those are the things we look at in the load analysis. And then we look at system sizing, and component selection. When we talk about system sizing, we talk about the capacity of the inverter system, the capacity of the backup. We talk about the battery, the power bank, the capacity of the solar panels, that is total capacity of the panels required to be able to meet the energy requirement. And the rules, the do's and don'ts, we look at all those things and we look at, so just to be able to have come to a conclusion on the exact system size that is needed by the client, that is needed in that area or space. And then we have 2D and 3D electrical design, 2D and 3D design or and electrical designs. Many engineers do not look at the necessity of having a technical plan, a draft layout of their installations, and it's a growing demand for it because many engineers have lost job opportunities because of poor presentation of installation plan, poor presentation of drawing, poor presentation of project plans, and uh, uh, these as limits them in order to get that job, in order to get that contract. And many are getting jobs today through proper design plan, 2D and 3D electrical design. So they have a proper plan and their solar panel layout show in their design, the electrical design or draft, how the panels will be laid, how the inverter will be placed. These things are part of the process involved in solar system design. The truth is, engineers, business men and women, which we are, and marketers, renewable energy system, people who are involved in this market, especially renewable energy. We need to start looking at more. We need to start looking at proper design, 2D and 3D, and energy yield analysis. That has to do with the energy generated from the solar in the day, within the period of radiance from the sun. Look at the peak yield and the least yield. And then with documentation and approval, submission of documents. Now, when I talk about documentation, it's when an engineering firm or solar firm has documentation, uh, electrical design drawing, as built drawings, it's much easier for them to run their maintenance. Now, it's really bad for engineers to be asking a client as to what is the capacity of the inverter they have after they have installed it for probably more than 2 years or 3 years. They don't know what's there. They don't know the size of the inverter system that is there. But when you have an as-built drawing, a CAD drawing, which comprises images of finished work, realistic images of finished work, it's much easier. So once the call is made from the client, we have an issue with our inverter, they can assess the as-built design, as-built drawing in their archive and study the system that is in the client's place so they can have a preview or perhaps a perception of what could cause the problem in the client has. It is very bad for engineers to be asking their clients what is the size of the inverter there, what is the name of the inverter there, probably due to proximity in distance. So once the engineer has an overview view of what is in the client's place in Lagos or in Abuja, and the client who is in Ibadan or some other place, they will not waste transport. Whatever it is that they need to take along, they will take along because they have already gone to the archive, checked their documents, and they have an overview of the system that's in the client's place. So it makes CAD drawing, CAD draft very important, very essential in in um, the solar business. So we need approval from the M&E consultant for large scale projects. So we need to submit our workshop drawings. So as companies, as partners, we need to look at um, uh, effective design, efficient designs, and the inculcate the habits of having a proposed design or a proposed draft and having as built for effective system management and profit optimization, and also proper maintenance of system. So we can through this documentation we can track the history of installation of our clients because we have a document that speaks about their work on site. They speak about uh, what is done by the client and what is done by the company in the client's space, a company or a residential building. Installation plan that has to do with when the project is going to be done, when the panels are going to be installed, how long is it going to take, the logistics, the number of labor that is required. These are the things that is considered in the installation plan for the project to be uh, consummated. So, importance of 3D system design. Number one, we have competitive advantage. Competitive advantage. Competitive advantage. Competitive advantage. Competitive advantage. So now, importance of 3D system design. Number one is competitive advantage. So delivers a professional cutting-edge presentation to impress clients and wins projects. So 3D solar system design impress the clients, and it has the power to win projects. Now, over 40 to 50%, there's over 40 to 50% increase that a contractor will have a project because he included or attached a 3D visualization to the project alongside with the traditional 2D and the bill of quantities that is standard. Personally, I've seen projects being approved because a 3D design was attached. There was higher percentage, higher. You can make your research that the project managers or companies that attach a proper presentation, like including a 3D design, they have higher chance of getting the project than one who comes with a 2D or just the bill of quantity to tender for the job. So it's important we look at 3D is really shaping, really opening more business space for companies because they have a visualization of the system outcome. So it gives one a competitive advantage. If you're an energy provider, you need to consider 3D solar system design. It will give you edge over your competitors. Not many people are looking in this direction. Many people are just focusing on buying and selling, but you need to get the job. If you don't get the contract approved, you will not be able to buy or sell. So many people are looking on installation. But as much as installation is very important, essential, we need to look at 3D system design. It gives them the edge. It makes them stand out, and it can make you stand out. You need to consider it. You need to look at it, and it's going to open more opportunities and give you an edge in the bid for a job. And also, when your client is aware that he can see and has built a design of his system even before the project is approved, he will buy into it because he knows how it's going to look like. It creates an impression of him, so he has a view. Something sticks into his heart and said, "This is how the project is going to be. This is how my space, my bathroom is going to be." He has the view and he expects something, if not 100%, something similar to what he has seen in your visualization that is presented. So, precision planning. With 3D, you can have a precise view of how the space is going to be, how the panels is going to be. You can have it will aid planning because from 3D you can move to 2D. You convert 3D to 2D. So shading simulation, it can be done. You can do a shading simulation, and the shading issue that probably may rise up in presentation can be dealt with because your clients, the people you're submitting your tender to are seeing the reality of the project when it has not been the pre-visualization of the project when it has not been executed. Then performance optimization, fine-tune stills orientation space to boost energy output. You can have a view of this optimization of the system with a 3D system. You can see with a 3D design, you can have a view of how of what the panels will generate. Now we have three PV systems, one of the effective software the PVCs, you can make calculations on on yield, and it is effective. And coupled with AutoCAD, you can have a very good presentation. So why use SketchUp and AutoCAD? Why do I use SketchUp? SketchUp is very easy to use. It's intuitive. It's easy. It's one of the easy 3D modeling software we have. Although we have advanced ones like 3ds Max. I use 3ds Max for large scale projects. I have a project here I want to show on in my SketchUp. So in this 277 kilowatt solar farm, I have panels displayed. Total number of 650 watt solar panels. So I have panels displayed here. I have panels displayed here, so you can see it. So this is SketchUp. So I'm using SketchUp Pro 2022 for this webinar. So this is SketchUp interface, and it's a number of scenes that I have for this project, and my SketchUp user interface. I'll speak more about the SketchUp software in the main tutorial series. Which I'm going to communicate at the end of this webinar. I'm going to post information about the webinar. Information about. I'm going to post some information about the tutorial coming up, training in AutoCAD and SketchUp.